But anyways, we have your PhD, right, Steve? Mm-hmm. Dr. Stephen Yuchs from Montrose who's going to talk to us. Dr. Yuchs has over 26 years of experience in source testing, project and lab management, execution of compliance testing involving relative accuracy test audit programs, contemporary continuous emissions measurement system installations, and process optimization programs. And if you thought that was a mouthful, you should, the next few paragraphs that I'm not going to read. He currently specializes in proton transfer reaction time of flight mass spectroscopy, PCR, time of flight mass spec, for sub-ambient level determination of pollutant concentrations, emissions, vectoring for point source leak detection and real-time determination of baseline emissions using a self-contained mobile laboratory. So thank you very much, Dr.
That was a mouthful. I don't know where that came from, but thanks for. So I promise I won't talk very much about PCR mass spec, which is my main area, but I do want to talk about some different baseline monitoring solutions that we offer, and I want to kind of do it in two phases as a progression from the past up to what's happening now and what's going to happen in the future. And then the second part, I'd like to talk a little bit about how we're going to manage all this data that's being generated with these systems. So we'll just jump right to that. A little bit about who we are. We are a worldwide company now. We have 70 offices in the U.S., Canada, and Australia. I assume it won't be too long before we're into Europe as well. We have over 2,800 employees. We moved recently from Irvine, California to Little Rock, Arkansas as our corporate headquarters. And you can see the dots. It's a little bit out of date. There are a lot more dots on the map now than there were for this. So we are nationwide, and we have we are an umbrella company. We offer all different kinds of solutions to environmental response, consulting, engineering, measurements. We have an air group. We have a water group. We have we have a PFAS treatment company. So we have a wide variety. We have a variety of data platforms and a lot of advisory services. So this is the formal abstract that we'll kind of keep covered because it'll be on the slides online. Try to keep it as informal as possible and just more of a communication than a lecture. But so I'm going to do two different phases. We're going to look at hardware and then we're going to look at software. The hardware has all these different technologies that we'll talk about, and then we'll talk a little bit about the software package that we have and what it can do in terms of management of your data. So the traditional sampling, I mean, it's been around for a long time now. I mean, the first one was somebody walked out and smelled something, so maybe we would do something. So it became a little bit more sophisticated with passive tubes, which is what the top picture is on the left. That's the tube holder. They're deployed in the cans on the bottom. And then we also use SUMA canisters, which are on the left side there. These are passive methods. Tubes are in place usually for 2 weeks, according to the fence line rig. Cans could go anywhere from an hour to 7 days, depending on how you set the timers. It's nice. You can measure that the tubes are usually for a specific compound, normally benzene is what we're doing all the breaks with. You can do other tubes, and we have done some studies with tobacco and other compounds as well. So they do work for other compounds, but right now they're mainly used for benzene. The SUMA canisters offer you the option to measure multiple compounds depending on what analytical methodology you use. It's a TO15 where you're looking at a set list. Problem with this, it's passive and it takes time. So if you get a hit on your tube and it happened the first day, out for 2 weeks, they go to a lab, it's another 2 weeks, you get the report back. Now it's 5 weeks past the event. And you see a spike in your tube, and now you got to correlate what happened. You can't. Something happened, but you don't know what caused it. Same with the SUMA canisters. So while it gives you numbers that are there, it's pretty antiquated, and it's not really helping us to solve any problem. So we're going to move up a little bit now, and that's the past. And those are still used all the time. We deploy them by the hundreds all around the country. So now we want to move forward a little bit, get a little more higher resolution, a little more modern So these are more of what you think of as traditional ambient monitoring stations. And these are the little buildings you see popped up here and there everywhere. They meet the NAC standards. They're doing all these different analytes that you can possibly do on them. And others, we also have a system set up in California for H2S and ammonia, as well as some of these other things. So there are multiple different kinds of instrumentation you can put into them. They have a very high degree of data quality, calibrated. They follow all the procedures. The data analysis is very set. The problem with this system is you have to have a building. So you have to build a building. The building stays there. You have to have a met station nearby. If you use met data that's 5 miles away, that may or may not be what's happening where the station is. So usually there's a station really nearby. So it's a lot of expense that winds up, and it stays there. You can't move it. Something has to come to it to see it. And while that has its place, that really doesn't help us much if we're trying to solve some issues. So we want to move forward. Sure.
That building has to be.
If you're going to have these analyzers set in, yeah. If you're going to have it set up in that way, that's why there's very few. And do you know how many there are in the Denver area where we're doing our mobile stuff as well? They have 3 or 4 of those buildings set up.
20-ish.
Oh, they built 20 of the buildings? Yeah. So I mean, you're looking at tremendous costs there. So, and they're there. They stay there. You've got to have power and everything run to them. So we wanted to look, what can we do that gets a little bit better than that? We want to move into the next generation. So we want to shift from these regional stations down to everyone wants to know what's happening in their neighborhood and in our area and on our fence line. So we have a variety of systems that we look at. Some are ours and some are competitors that we use. But on the far left there is our little S5, which Montrose was talking about earlier. It's very similar technology, different manufacturer, obviously, but it's a TVOC sensor down at the part per billion level. It's completely self-contained. It has its own solar power system. It has a cellular data built into it that communicates up into our software package that I'll talk a little bit later. Very nice, not specific. So we're going from a shorter time interval because these can report data every minute to the tubes from 2 weeks. Now we're going to every minute, but we have no specificity with the TVOC monitors. It's TVOC. So another answer to that, and those have a great place, and we use them all over, and I'll show you some examples of those later. They're great indicators. They work really well. But for most applications, you want to know what it is that's crossing your fence line as well too. And if you see the little picture on the bottom right, that's the setup that actually goes with the next picture. So I'll jump back and forth real quick. So, one of the ways that we do this to get more specific are these auto GC systems that we use. NMET makes a fantastic one. There are other ones that are well. We have a good relationship. These are portable. Myself and one of our technicians can set it up in about 4 hours, from out of the box and up and running in about 4 or 5 hours. Depends if we have 2 strong technicians, it's faster, but I don't take care of stuff very well, so or Matt has to do it all. But it's easy setup. You can come in. It's got a very small footprint, not much bigger than this table. We also put them on trailers, now little landscape trailers, so we can just hook them up and pull them wherever you want to. So this is the engine that drives it. Bottom left picture is the actual setup that you see. It's got the 3 big solar panels. It is completely self-contained. It doesn't need any power. We don't use that weather thing that's on there. We have a little bit more sophisticated one than that. But that's part. This unit is fantastic. It will speciate your VTEX out for you. It does have baseline separation with cyclohexane, which is a problem for a lot of applications. So you can make sure you're separating out the cyclo from the you can look at other ones if you want. The low detection limit, we calibrate these every 6 hours with a 10 ppb cylinder that is attached to the system as well. Keeps it calibrated. They see well below ppb. There is a couple downfalls with this too. It has a short integrated sample time. It grabs a sample in about a minute and shoots it in. We are working with them to develop a continuous sampler that will kind of not an absorbent type module, but kind of something similar to that, so that you're actually looking at the whole time. So it'd be almost like a turret where you're collecting for 10, analyzing for 10. So that's in development now, but we still get really good numbers. Every 10 minutes, you get a VTEX number out if you want it. Like I said, there's no shelter. We don't have to build a building. We don't have to run power. It's out there and it's all contained. Sorry. Oh, yeah, it's the data system. I'll show it to you in a bit. Yeah, it writes everything up to the software package that we include with everything. So that's great. Still kind of hard to move that around. Even, you can put it on a truck and move it. The other options, we want to look at more points. We're still looking at one point in spatial time and spatial resolution there with either the buildings, the portable GCs, or the S pods. They're all sitting or in one location. That's great if you happen to be where the plume is, or what you see is what you're looking for. But if it's 500 yards down, you're going to miss it. So we're looking for systems that will cover more of the fence line in more real time. One of them is the Xerox sound system and Bus UV3000. These are UV-based systems. They're extractive, so they're continuously sampling. You can move them around. The Xerox one has a Pelican case with little wheels like a computer bag. And then the hose, you can sample and move as you go about. They can run about 4.5 hours on a battery charge, and then you got to hook them back up. So a lot of times what our people do is they put them in the back of like a golf cart and plant, or one of those little gators, and they drive around with those. It's got a built-in GPS, so they know exactly where they are, what they're sampling, what they're seeing. It all gets recorded and sent out. It is more expensive. It's a more expensive system. I mean, it's more sophisticated, so it's more expensive. It is portable. It's very low maintenance. It's all sealed, so it's pretty easy to clean it out and keep it going. The detection limits can be an issue depending on the environment. Because it's UV and you're looking at somewhat broad absorbance bands versus IR, you can get a little bit of overlap if there's, I'll tell you, in one instance, we had it on a fence line at a property, and then across the fence line on the other side was a tank farm that trucked in and out all kinds of different stuff. So the backgrounds were always changing on what these people had in the tanks. So it became a real exercise in narrowing it down. And it took about 2 weeks to really get it dialed in and minimize all the interferences. So there is a little bit of that because it is more sensitive if you're looking for more interferences. But once it's set, I had one sitting in a trailer just because they wanted to use it as a test for 4.5 months. And I went out twice. Once I cleaned the air filter. Once I just needed to check because it's been so long that I didn't, make sure everything was okay. But you can log in. I logged in every day, looked at it, ran gals, whatever I needed to do remotely. So it's all integrated that way. Usually data point per second. We usually do a minute. Data point a second is a lot of data. So now we're moving from stationary to a little more mobile system. We're still getting the detection limit, but we're getting more and more real-time data. Still doesn't tell me what's happening down the entire path. We need to know what's crossing the fence line at all different places. So one way that we really like, and I can speak on this more if you have questions later, but it's open path technology. So now we're looking down the whole segment of the fence line. We can see up to 1,000 meters. It's 500-meter path each way. So it goes down, it bounces back. So you have an energy source, you shoot it down, it hits a retro, and it comes back. That's the open path FTIR systems, or open path UVLF systems as well. They do the same thing. I'll show you some pictures of what they are. Real-time data every second across the whole fence line now. So if something happens 500 yards away from your sensor and it doesn't pick it up, you may still see it on the open path. So that's kind of what we're looking at in the top picture. You can have point samplers along the whole fence line. And what you're going to get on that bottom point sensor is a lot less than what you're going to get on the center one, because that's one of the big downfalls of the system. It can't tell the difference between, if you look at the bottom ones where it says 100 ppm meters, it can't tell the difference if that's 10 ppm across the entire path length, or if it's 0 ppm across 90% of it, and 100 ppm in the middle. It all comes out to the same number because it's averaged over the path length. So that's kind of it's not really a downfall, but it's kind of one of the shortcomings of it. Usually it's never that way. You don't have a very narrow band that's crossing your fence line at, in a 10-meter section or a 5-meter section. So it can, and if you have point sensors along the way.
That's what I average.
An average across the path line. Well, I'm not exactly sure on the mechanics, but like on the bottom one, see where you see all the zeros across, you see the average. So you get a ppm value that the spectrometer reads, and then that's per that distance that the record was set from the actual source. So the path length of 500, let's take that concentration number over that meter distance, that's your value. Correct.
I think the question is because
Oh, right, yeah, that's right, that's maybe not very. Yeah, I hadn't thought of that too, right, so I just wanted to mainly to say that it can't really tell the difference between a broad path across it that versus a narrower, higher concentration. You're gonna see basically the same number. And that's great, so it's really a great alarm system. It really is across the entire fence line, and that's kind of what they're used for. And I'll show you an application of it right now that will hopefully make this a little. A lot of people aren't familiar with these. This is what the equipment actually looks like. Have a source. That one in the center is our little dog house that we pull out, and it's got the turret in it, and it turns and it shoots lasers, and turns and shoots the other one. So, that's a multiple pathing system. That's what the reflectors look like. You need a vent station set up nearby so that you can get some correlation between speed and wind direction. That's all part of what. And you can also do this. There's a tunable diode laser one that we use for hydrogen sulfide. So they're all basically the same, but it's a laser you shoot across the lake and it comes back and read the optical torque. Just gives you a really big path length now, so you can see what's going across your fence line. What kind of looks like when they're deploying one now. Of course, the orange lines aren't there, but that's the path that the laser would go. I'm not sure exactly why we had so many retros. That's more of the system. The guys are out setting it up. And it does take an engineer a couple days to get it set up and lined up and optimized, but they do work very well. You need a source of power. You can do it with a small generator, or you can tap into a line source somewhere. Everything is sealed, so it's pretty easy. We have a technician that will go out and make sure it's aligned. It does a self-alignment, but it needs to be aligned. They clean the optics off, and you're operating. These are designed to run unattended for long periods of time, and that's what all of the systems that we have do. So now that's across the whole thing. So now if you get an alarm across this fence line somewhere, you need to find out where it is. So you need to have a way to mobily go out and go down that fence line and find out where it is. We do that with the TRMS van that we run. It looks kind of weird, like a van is pressed together. It looks like it's actually pretty long. It's a big thing, but it's completely mobile, it's self-contained. It has a high resolution mass spec in it. We don't need to go into this. Just out of curiosity, say in the bottom left corner, you ever go by a landfill and smell it? That's what it looks like in a mass spec. All those peaks down below came from a landfill that we were testing. So those are the odors, aldehydes, and ketones. That's what a landfill looks like if you were going to. So what do we do with the van as it's driving? We are going to generate a real-time fence line picture, and that's what this is in this slide. This is an older software package that I still use, but not as much as I do the current one I'll show you. This is a complete VTEC shot down a brownfield fence line is where we're driving there. So if you had an open pad system set across, or if you had sensors, you would have readings, but you wouldn't have the complete picture of where there's a really large spike of the B-text and xylene coming out, very small area versus, the rest of the test application. This we do in real time. It's easy to see. It's graphic. Set your colors as you want to, concentrations. But it really shows you down to about a 5-foot section is about how far we travel in a second. So we get a data point every second, about 5 feet. So you're getting data points right on top of each other. And of course, just for the future, things that we're looking at in the emerging tech side. So we're going to go from even more data generation to an even bigger picture now in real time. And we have a couple of methane drones that we use. There are fixed wing aircraft that do this. They're low Earth orbit satellite systems that they're probably in place in another 10 years that will be over an area. They all generate what people want to know, which is a concentration maps and where the stuff is. So, and that's kind of where the field is good. Each step along the way, as we're moving down this path, we're generating more and more and more data. An 8-hour day for me in the van, I generate about 5 gigabytes of data. I mean, it's a huge amount of data. It all has to be stored and kept. So we're generating all this data. We need some way to present it to the clients, or you as clients, you need to present it to your people or your management. That doesn't make sense. I could hand you a printout stack of all the results that's 3 feet high and say, here your data. But package handles this. And our package is the AirSense Sensible Environmental Data Platform that a good friend of mine developed along with Pat. This package covers everything. You can import tube data. You can put in canister data. My portable mass spec data goes in. All of our sensor networks feed into this system. Open path systems feed in. Anything in the future that will be developed will be handled in this package. So we've tried to set this up as similar to the Molex people, make it more easy for the client to use. When you open it up, it shows you where you are. So since it was in Austin, I thought, well, I'll put the Austin screen in there. So this is what it looks like. Every client has a login. You get in and you'll have access to all of your data. The nice thing about this, it's scalable. So as an environmental manager, you can set a level where you can see and do everything. You can have technicians who will have a level that they come in that they only see a particular sensor system that they're involved with. Let's say they're the SPOT group. They only see the SPOT data. They don't see the entire picture. Very scalable, very custom. You can put the data. This is a data visualization tool. That's really what it is. It makes it a lot easier to see. This is not standard. Everything on it is customizable. This happens to be some kind of public data that we can display. The hard part of this is all the data that we have is client data and it's confidential. So it kind of makes my presentation hard to show the really sophisticated stuff because that's all proprietary. But so this is just a simple set of sensors, like they were talking about the Molex. These are the sensors that we use. You can log on, you see your current readings, you see your 15-minute average, your 12-hour average, you can see your daily average, your 7, whatever you want to see, it can be set up to do. You can make pollution roses, you can make wind roses. The nice thing about it is there's multiple ways to display the data. Some people want to see it this way in the squares with the numbers. Some want to see it graphically. Some want to see the line graphs. I personally like the line graphs because it's easier for me to look at the whole mess of sensors there. See the one that's spiked, really easy. Say, okay, we need to look at this and see what's going on. So now you dial in and see what's really going on there. One of the biggest advantages of this system, one of the things that our clients like the most is the alerting system. It's great to have all this data, but if you have to go back through it and dig out a problem that happens 10 days ago, that's no good. So we have a couple of different kinds of alerting systems, and I'll talk a little bit about them. These are real-time alerting systems. If you so you have a sensor that you're interested in the middle of a process unit. If it gets over 500 ppm on a TVOC reading, you want to know about it. And send somebody out there to look. So this system will set up an alert that will send it to whomever you designate on the tree. Usually it's the environmental manager, and then if it's a spot or something, it would be the technician responsible for that area. It will alert them. It will keep alerting until someone acknowledges it so that they can't say, oh, I didn't see it. It will keep alerting until you actually tell it not to. And that's all very good for record keeping as well too. So it sets out the alert. Now you don't have to go out and look for it. You know exactly which ones, high or not. So that's a really big part of the system. The other one, and we use this top one a lot for SEM systems. We're now writing SEMS data, stationary source SEMS record keeping data into the system for a couple of clients. This monitors each individual component of it. If the analyzer goes down, you have X amount of downtime, you're allowed for a quarter. And this starts keeping a clock on it and sends alerts saying, hey, your NOx analyzer isn't working. It hasn't responded in 5 minutes. You need to check this. And it keeps going and it keeps that all logged for you. And then the other set of sensors that or trips that we usually set are the values, you're above a limit, you're below a limit for some reason. Hey, this sensor is rising at a pretty rapid rate for the last hour. You may want to send somebody out to look at it. So any kind of alert that you want to send, this you can design the system to do. And we'll do it via email, text, phone, a phone app. This is all app based as well. You can do it on your phone. We really like, and our clients really like, that you can send it out to the operators and the technicians out in the field right away. There's an alert. They can go over and say, hey, sensor 1407, something's wrong with it. You need to go out and look at it. It will pop a link. They hit the link. It'll pull up a GPS map and show the sensor on the map and show exactly where they need to go. And once they get there, they can update on their phone. Fell over or something, cable came out, something like that. And then that's all logged in the system. Now becomes part of your report. So we'll talk about. I put him in every presentation somewhere, but so this is a little bit about what I was talking about, and this is the other part too. It will log this and will tell you you have X amount of downtime. It tells you when it's off. You sent somebody to look at it, or someone's acknowledged this happened. Someone's acknowledged that, yeah, I looked at it, but they didn't really go look at it. It was raining, they didn't want to go out, felt like they were going to do it later, forgot about it. It will come back again and say, hey, still offline. Something's not right. And then the other nice thing is you can set and say, hey, now it's back up. So now you plug your downtime to a certified analyzer. Hey, you get 2.5 hours downtime now on this. You've accumulated, it keeps it running forward. There's a variety of different ones you can set it for on, off, high levels, low level. And again, this is the sensor level. This is what one of the pages is like. And the nice thing about this is you have a login and you can set whatever you want as the environmental manager, as the head of the operations, whoever's responsible for it. If you say, I want to know when this sensor hits about 35, you set it in there. If you say, I don't want to do all that, I want you guys to set this all up for me. I want an orange bar that comes across when I get above 500 ppm. We'll set it up for you. It's all in the database. It's all part of your network. When you open up and log in, it'll all be right there. So now we're coming. This screen looks really busy, but it's one of my favorites because this is an entire sensor network that is set up. These happen to be all M2.5 sensors that are set up out in Colorado. You can log in and you have everything set, and you can look at a glance and instantly know that, hey, everything looks really good here. It's 95% green or yellow. I've got a couple oranges that I may want to look at those. Gives you your whole network's readings without you having to spend 2 hours digging through individual lines of data. It's all right there. Easy, you can customize it. It's really nice. And these are some of the scales. You can set these to whatever you want, but usually if you get a purple or a really dark red, it's not a good thing. So all this is scalable. I have a client who will not use red. So the highest level warning is yellow. So when it gets the yellow, that's their red, and that's easy enough to set up. So we can do that. mostly they're PM 2.5 networks because it's a public data set, so anyone can look at it. Easily TBOC, OpenPath, UVDOS, anything you want to put into this, all work in the same fashion. And of course, no one wants to do the reporting on all of this, so we have built-in templates and systems that will take your data weekly, monthly, quarterly, however you have to report it, compile it all into a report, sets it out for you. If you want to include lab results that are different, it'll import those. For downtime warnings, it'll do the regular data. It all comes out, you look at it, you're done, send it in, taking care of it. It's really helps your report. So now I want to look, because I do have to talk about mobile data, because that is what I do. So I do have to talk about this. So the mobile data that I generate is a tremendous amount of data. We usually out, 8-10 hours at a time, you get all this data. And you have to have a way to present this. You can't make those Excel maps all the time with the graphs. You can do it, but it's not real time. You can't see it. I have to do that later. So you may miss something along the way. I usually see it, but graphically. So Matt did a lot of customization for our data sensible data platform so that we can get it directly in real time and create these 3D open-based satellite pictures of the data as you're going on. This happens to be nearby. Not sure. Oh, I did simulate the fence line. This was last week. Although it's not a fence line, this is a emergency response fence line that was set up around a environmental recovery that's ongoing currently right now. If you're really good with the maps, you may be able to figure out where it is. But the green circle is repetitive laps around this perimeter fence line. Another was an EPA vehicle. In front was us behind. We're both mapping this for a correlation study. I think that's about 4 hours worth of data right there. So you can see everything is green. Their alert levels set at their threshold levels. Anything below 20 was green. So, but this that we're covering, and it's a fairly small area, but it's still hard to see what's really going on here. You can zoom in, now you're getting a little bit closer, and now you can start to see the individual data points that are stacking in on top of this. You just go to a much smaller, lower level. What I couldn't capture on this is one of the really key features is it has a hover function. So if you move your mouse point over one of those data points, it pops up the date, time, concentration, wind speed, wind direction. It gives you a whole. I do mapping like this in one location for 68 compounds simultaneously. So you can go into this mobile dashboard. I can tell them which one it throws up. Throw it I can sign it. It all comes up. You hover over, it tells you what we're using this for is to determine areas to put open pass systems. So we're taking this data, all of this, anything over a certain value we're plotting out, and we're looking at those values over 10 parts per billion. Anything that's over 10 parts per billion has to be in one particular area. We're going to set up an open pass system now to monitor that. We have a real-time record of data for work exposure. And we do the very same thing along fence lines and plan for do this in communities as well to look at health monitoring. So it's all kind of a whole set of tools that work together really well. We use the mobile on the fence line to determine where we need to set the S-pods. I mean, you could just kind of randomly set them out and hope you get it and it's representative. Or you can come in and kind of map out where you think your emissions might be and then place the sensors. There's same with the EGCs and the open pass. There's no real sense of setting up an open pass system where there's no measurements. I mean, they're not cheap. So you really don't need to monitor unless you're required to monitor it by statute, which some places are. But you don't want to do that in an area where you're not going to have anything that's not really going to tell you what's happening. So this tool is really big part of helping you lay out where you want to put it. And then the last thing that I want to talk about is we also use this to do source identification. I know Melissa was talking about this earlier too. We use a different kind of technology than they do, but it's very similar. So the green pins here represent TVOC sensors that are set out. This is an upstream production facility. Let's see if I can get this to work now. So you have your upper data, which is the graphical orchestration. The blue is wind speed, wind direction. The bottom lines are the TVOC numbers. You can see when the wind's coming out of the north, they're around 310, 320. So it's coming straight this way down. You're not seeing anything on your sensors. The wind shifts now and comes in this direction. You can spike up in the TVOCs. So we take that. Oh, am I out?
Question time, if you can wrap up.
Okay, yeah. We can use it. We determine where the leak was coming from. They sent someone out, a wellhead covered, popped off. They sealed it back up, and their emissions went way back down. Basically, including everything we're talking about, we're moving to more and more sensors in more real time fashion. But also, it depends. Right now, terrible. No, it depends on where it is. It's located in Texas. We were in Pennsylvania in a day and a half for this one. We've been in Chicago. It's basically about 6-8 hours plus the travel time to get there. And we usually have someone available to get it there and get it going. Now, it does have a lot of high use. We're currently looking at another one to build another one, but yeah, it can respond very quickly. It can, other times it could be 3 or 4 days, depending on where it is.
So you just have one RMS pen, right?
Right now, right? Yeah. It was a little over $1.5 million, I think about $1.25 million to build and equip out. So,
I know.
yeah, and we're really looking to build another one. Maybe not quite as sophisticated as this one. This is a very high resolution instrument that we use. We could probably get by using one that's not quite as high resolution. So, anything else? Thank you.
Thank you very much, Dr. Yuchs. We appreciate it. If you have questions, Dr. Yuchs, you can come later, as well as Matt from Denver, also with Montrose.
And Jenna can answer. She's a part of. She's a Gulf Coast operations manager. She knows the data platform much better than I do. So.
And there was a sign-up sheet going around. Somebody walked off with the last session sheet, so I don't want to lose this one.